Good morning, everyone. I'm your host, Samuel Chung, and this is Quantum Chempardy. Before we start this game show, let's introduce our three lovely contestants here today. Contestants?
Good morning, everyone. My name is Alex Moran. I'm a fourth-year chem major, and I'm here to win this show.
What's up, everybody? My name is Owais Ali. I'm a fourth-year chem major at UC Merced, and I'm about to take this home.
Hello everyone, I'm Alexander Goga, and today I'll be joining this show as a fourth-year chem major, and my bio is emphasis for biochemistry.
And what lovely contestants we have today. Thank you, contestants. And today on this game show, we have 5 categories.
Electronic states. Figures and diagrams. Jablonski diagram. History. Fluorescence or phosphorescence.
Okay, this is electronic states for 100. The prompt is the name of the singlet ground state representing the lowest energy electronic state of an atom/molecule where all the electrons are paired.
What is S0?
And this is electronic states for 200. The prompt is the name of the first singlet excited state where an electron becomes excited and moves to a higher energy orbital while remaining paired/antiparallel with the other electron in the original orbital.
What is S1?
And the category is electronic states for 300. The prompt is the name of the excited state where the spin of the electron as it is excited to a higher energy orbital is flipped so the electron in the original orbital and the electron in the higher energy orbital now have the same spin.
What is T0?
And the category is electronic states for 400. The prompt is the name of the excited state that is higher in energy than the first singlet excited state where an electron becomes excited and moves to a higher energy orbital while remaining paired/antiparallel with the other electron in the original orbital.
What is S2?
And the category is figures and diagrams for 100. The prompt is the states represented in this visual.
This is light work. I got this. What is singlet ground state, singlet excited state, and then the triplet excited state?
And the category is figures and diagrams for 200. The prompt is the name of this figure.
What is Jablonski diagram?
And the category is figures and diagrams for 300. The prompt is the phenomenon depicted in this graph.
What is the Stokes shift?
And the category is figures and diagrams for 400. The prompt is quencher.
What is particle in a box?
Sorry, contestants, none of you got that right. The correct answer was, what is a molecular substance that facilitates the non-radiative pathways of a molecule going from the excited state to the ground state and thus decreasing the intensity of light emitted during luminescence? The category is Jablonski diagram for 100. The prompt is the process where a molecule in its ground state absorbs a photon and has an electron excited to a higher electronic state.
What is absorption?
And the category is the Jablonski diagram for 200. The prompt is the process where a molecule loses excess vibrational energy and moves down the vibrational levels of the electronic state until it reaches the lowest vibrational level of the electronic state.
What is EV?
Ooh, none of you got that. The correct answer was, what is vibrational relaxation? And the category is the Jablonski diagram for 300. The prompt is a non-radiative process where the vibrational energy levels of a higher electronic state overlap with the vibrational energy levels of a lower electronic state, causing the molecule to transition from the higher electronic state to the lower one and converting electronic energy to vibrational energy during the process.
What is internal conversion?
And the category is the Jablonski diagram for 400, the non-radiative transition between the excited singlet state to the lower energy triplet state caused by spin-orbit coupling.
That work. What is intersystem crossing? Get out of here. This is my game.
And the category is history for 100. The prompt is the law found in the experiment recorded in 1852 in which one part consisted of moving a solution containing quinine through the visible spectrum resulting in nothing, and the ultraviolet spectrum where the solution glowed a blue light, leading to the conclusion that the dispersed light was always of longer wavelength than the incident light.
What is Stokes' law?
And the category is history for 200. The prompt is fluorescein, which was first synthesized in 1871 by Adolf von Baeyer, through a condensation reaction between phthalic anhydride and resorcinol with a zinc chloride catalyst.
I've seen this before. What is the first synthetic fluorescent dye?
And the category is history for 300. And the prompt is Edmund Becquerel's contributions to photoluminescence.
What is useful science?
What? Yo, get him out of here.
And no one got it that time either. The correct answer was, what is measuring the decay times of the phosphorescence of various compounds using his phosphorescope, built in 1858 up to lifetimes shorter than 0.1 milliseconds. And now that we have reached the end of our game show, it is time for Final Chempardy! The category is fluorescence or phosphorescence. The contestants can each wager as many points as they would like for this question. And the prompt for Final Chempardy is explain fluorescence and phosphorescence, including the difference between them. Alexander G bet all of his points and got the answer wrong. So now he ends with 0 points. Alex M also bet all his points and he also got the question wrong. And now our final contestant, Oasis, also bet all his points, but he got the question correct! And now he wins Final Chempardy! And now with the final end of our game show, I would like to thank the audience for watching and to Professor Isborn for giving us a great semester.
Thank you, Professor
Professor Isborn.
Thank you.